Okay, so today we're going to discuss lesson 1.6, solving compound and absolute value inequalities. So in the past, you solved one-step and multi-step inequalities. So today we're going to solve compound inequalities, solve absolute value inequalities. So our vocabularies are compound inequality, intersection, union. All right, let's start with the key concept. What do you mean by and compound inequalities? A compound inequality containing the word and is true if and only if both inequalities are true. So when you say compound inequalities, there are actually two inequalities being put together. So example, x is greater than or equal to -4, and then the second inequality is x is less than 3. So if you're going to put this together, it's gonna be x is greater than or equal to -4 and x is less than 3. So you can also look at their corresponding graphs. So the first one is closed circle because of the line under the greater than and pointing to your right. And the second one is open circle because there's no line under the inequality sign. And then put these two together, you get the intersection between the two above graphs, and this will be the result, which makes it compound inequalities. Okay, let's have an example. Solve 10 less than or equal to 3y minus 2 less than 19. Graph the solution set on a number line. So guys, for this problem, you have two methods of doing it. So let's start with the first method. You're going to solve this separately. So the first inequality is going to be 10 less than or equal to 3y minus 2, and the second inequality, 3y minus 2 less than 19. And then just work it out and then solve for y. Okay, so add 2 both sides for this and then divide by 3. So y is greater than or equal to 4. And then the other one, do the same thing, add 2 both sides, divide by 3. So you get y is less than 7. So put this together because this is a compound inequality. So 4 is smaller than 7. So 4, you write 4 first, less than or equal to y, less than 7. So that is our first method. Second method, you can solve them together, both of them. Okay? So 10 less than or equal to 3y minus 2 less than 19. So your goal here is to isolate y by itself. So you need to get rid of your numbers in the middle part. So follow reverse PEMDAS. Okay? So I'm going to write it here. We're going to do reverse PEMDAS. Reverse PEMDAS. So you're going to start with subtraction, addition, division, multiplication, exponents, and then parentheses. Okay? In order to isolate your variable y. So we're going to add 2 in the middle. You're going to add 2 in the right. You're going to add also 2 in your left. So you're going to do this 3 times. Okay? So that will give you 10 plus 2 is 12, less than or equal to, bring down the 3y, the 2 will cancel, and then less than 19 plus 2 is 21. And then after that, you divide each term by 3. 1 in the middle, 1 in the right side, 1 in the left side. And then that would be your answer. So 12 divided by 3 is 4, less than or equal to y, less than 7. Okay, so you've noticed that your answer is the same. And then you graph them, and this will be your final graph. 4 less than or equal y less than 7. Alright, check your progress. Let's have another example. Try this one. 11 less than or equal to 2x plus 5 less than 17. So you can use either method. Method number 1, you separate this into 2 or solve together. If I were you, I'm going to solve this as 1. Okay, that's the easiest and faster method. So I'm going to subtract 5 in each term. So that will give me 6 less than or equal to, bring down the 2x, less than 17 minus 5, that gives me 12. And then divide everything by 2. So you will get 6 divided by 2 is 3, less than or equal to x less than 6. Okay, so that's our compound inequality. So our best answer here is letter D. 3 less than or equal to x less than 6. Alright, let's move on to another compound inequality using the word or. A compound inequality containing the word or is true if one or more of the inequalities is true. So you need only at least one, not necessarily both of them to be true. X is greater than or equal to 5. X is less than negative 3. Put this together using the word or. So x is greater than or equal to 5 or x is less than negative 3. So you have noticed, guys, that the graph are in opposite directions. So this one's going to your right, this one's going to your left. So put this together. So these two will not meet. Okay? Alright, example. Solve x plus 3 less than 2 or negative x less than or equal to negative 4. Graph the solution set on a number line. Alright, so we're gonna follow the first method. We're gonna solve this separately. Actually, there's only one method here because they have to be separately done. X plus 3 is less than 2 or a negative x less than or equal to negative 4. Minus 3 both sides, so you get x is less than negative 1. Same thing here. Get rid of the negative sign. Either you multiply both sides by negative 1. So this will turn to positive x. That will turn to the positive 4. Or you can also divide this by negative 1. Both sides, you will get the same result. Okay? So this is the graph of x is greater than or equal, greater than negative 1. So open circle. And then the graph of x is greater than or equal to 4. There's a line under, so close circle. Put this 2 in one number line, so the final answer is the third graph. Okay? Alright. Check your progress. Try this one. What is the solution to x plus 5 less than 1 or negative 2x less than or equal to negative 6? Graph the solution set on a number line. Alright, our best answer here is letter A. X is less than negative 4 or x is greater than or equal to 3. Okay, let's move on to absolute value inequalities. So remember, absolute value, there are two possible solutions, one for positive, one for negative. Okay? Alright, let's work on this. Solve 2 greater than absolute value of D. Graph the solution set on a number line. Now, if I were you guys, I would switch this 2. I'll put this in the left and then this one in the right. But both will you will come up with the same answer. Okay? So 2 greater than absolute value d means that the distance between d and 0 and the number line is less than 2 units. To make 2 greater than or equal to d true, you must substitute numbers for d that are fewer than 2 units from 0. Okay, so using a number line, you can also illustrate it here. So the numbers are -2, numbers smaller than -2, or greater than -2, and smaller than +2. So all of the numbers between -2 and 2 are less than 2 units from 0. Okay, let's have another one. What is the solution to the absolute value of x greater than 5? Okay. Alright, so what is our best answer here? So letter B. So you're going to plug in numbers greater than 5. So that would be to the right of 5 as well as to the left of -5. Because if you're going to plug in, let's say -6 here, absolute value of -6 is 6, which is also greater than 5. Alright, another example. What is the solution to x, absolute value of x less than 5? Okay, so what are the possible numbers less than 5? So that would be 4, 3, 2, 1, 0. What else? As well as -5 greater than -5. Okay, so -5 less than x less than 5. Alright, let's move on to absolute value inequalities. For all real numbers a, b, c, and x, c is greater than 0, the following statements are true. Okay, absolute value inequality. If the absolute value of ax plus b, close absolute value greater than c, the compound inequality is OR. Okay, if the absolute value ax plus b, close absolute value less than c, so you will get AND. Okay, so greater is greater, meaning greater and OR, and then less than less, you're gonna use the AND. Alright, let's have an example. Solve the absolute value of 2x minus 2 greater than or equal to 4. Graph the solution set. Okay, so greater, we're gonna solve this in 2 ways. 2x minus 2 greater than or equal to 4, that's the positive side, and then 2x minus 2 less than or equal to -4. Then solve each inequality, add 2 both sides, so you will get x is greater than or equal to 3. And then this one, add 2 both sides, divide by 2, so x is less than or equal to -1. So that is your final answer. Next is a word problem. Okay, so to prepare for a job interview, Hinda researches the positions, requirements, and pay, and she discovers that. Okay, so you have to rewrite the absolute value inequality since this is less than or equal. So 2450, your first lower limit here is -2450. Bring down 38,500 minus x less than 2450 positive. Because this is the less than, so you're gonna use the AND compound inequality. And then subtract 38,500 and then make your x positive. Okay? That's it. Thank you for listening.